Hi, my name is Terry, and in this video, I'd like to show you how to solve some exponential equations. So let's go ahead and get started. Let's first start with some examples of what exponential functions are. Okay, so an example of an exponential function, if you had f of x, okay, f of x equals 3 to the x, this is an example of an exponential function. An exponential function is a function that has a number in the base, a variable in the exponent, okay? So another example of an exponential function, maybe we have 5 in the base raised to the x squared power. So if you have a number in the base, variable in the exponent, that's an exponential function, okay? Not to get it mixed up with an algebraic function. Algebraic function has the variable in the base with the number in the exponent, okay? So this is your difference between algebraic. Okay, so an algebraic function, if I want to call this f of x, all right? So now algebraic function has the variable in the base, okay, with the number for the exponent, but an exponential function is when you have the constant in the base variable for the exponent, okay? So this is what the difference is. We're going to solve equations with exponential functions today. So that's what we're going to work on now. Before we start solving equations with exponential functions, let's take a look at some of the laws of exponents that we need to review. Some of the laws of exponents. The first law over here on the screen, the first law of exponents, anytime you take a base to a power, okay, so it could be a number base to a number power, so base to a power times a base to a power. The first one is when you're going to keep the base, okay, and then you're going to add the exponents. Let's say we have x to the second power times x to the third power, okay. So this property that we're going to need to use, okay, so this property right here we're going to need to use is when you're going to keep the base, all right, and then you're going to add the exponents together, okay. So x squared times x cubed is x to the fifth power. All right, so if you can see how that works, it's because we have x times x. We have two x's here, all right? X squared is x times x. X cubed is x times x times x. You have 3 of them here, so we have a total of x to the fifth power. We have 5 total, okay? Your next law of exponents, what if you're going to take and you're going to raise a power to another power, okay? So what if we want to take x squared and raise that to the third power, okay? So what does this mean? Well, this is where you're going to keep the base, and you're going to multiply the exponents with this situation, okay? So this is what you need to keep straight. This is where you want to take the base, keep the base, multiply the exponents, all right? This right here means we have 3 sets. We have an x squared, we have 3 sets of x squareds. Okay, so we have 3 sets of x squareds, all right? 3 sets of x squareds. We have 2 of them here, we have 2 of them here, we have 2 of them here. There's 6 of them, okay? So anytime you raise a power to another power, that's when you want to multiply the exponents, okay? So we want to make sure when we're solving exponential equations, we want to make sure that we've got these rules down. So if it's a variable, if you have same base, different exponents being multiplied, you're going to keep the base and the exponents, okay? But if you're raising a power to a power, this is where you're going to want to multiply the exponents, okay? All right, so that's the first couple. All right, so the first couple of laws. Let's take a look at the third law on that page, okay? So the third law over here, anytime you take a number, if we take a number, a variable, okay, raise it to a negative exponent, okay? So 5 to the negative 1 power, that's going to be 1 over 5 to the positive 1 power, okay? Anytime you have a negative exponent, you can change the negative exponent to a positive exponent just by moving it to the denominator. If you have 3 raised to the negative 2 power, this is going to be 1 over 3 to the positive 2 power, okay? So this is how you can go ahead and switch this around, or it's going to be 1/9, all right? So this is how you would handle a negative exponent, sorry. And then finally, anytime you take a number, okay, take a number raised to the 0 power, that's always equal to 1. All right, you take any number, raise it to the 0 power. Okay, so to try to show you a little example maybe as to why this works, if we take 3 to the second power, okay, and we multiply that by 3 to the negative 2, okay? So applying your first rule, okay, so let's apply the first rule here. Applying the first rule, because the bases are the same, okay, and the bases are the same, we're going to keep the base and we're going to add the exponents. So you have 2 plus a negative 2. Keep the base, add the exponents with this rule. Add these exponents together, you have 3 to the 0 power. Well, 3 to the 0 power, but what is 3 to the 0 power? Let's go ahead and compute these. Let's compute these numbers here, because I'm using numbers, so let's compute them, okay? What is 3 to the second power? 3 squared is 9, okay? And then what did we say that we can do with 3 to the negative 2? Well, 3 to the negative 2 is 1 over 3 to the positive 2 power, okay? So in other words, this is 9 times, and then 1 over 3 to the positive 2, this is 1/9, okay? And when you take 9 and multiply it by 1/9, you get 9 over 9, which is 1, okay? So that implies that, 3 to the 0 power must equal 1, okay? You can do this with every set of, this is not a mathematical proof. It's not a mathematical proof because to write a mathematical proof, I would have to show this with variables to show it's true for every number in the number system, which is impossible to do. So, but anyways, here is an example to show you. So when you're taking a number and raising it to the 0 power, it's going to work out to be 1. You're going to have this situation going on every time. Okay, so we're going to do 4 exponential equations examples right now, and so wanted to make sure that we had the review of the laws of exponents down, so when they're inside the problems, we'll see exactly how we need to adjust to that. So let's go ahead and start with example number 1. All right, so let me write example number 1 on the board, okay? So example number 1 is we're gonna take 3 raised to the 2x minus 5 equals 9, okay? So here's example number 1. We're gonna take 3 raised to the 2x minus 5, we're gonna set that equal to 9, okay? So this is an exponential equation. We wanna solve for x. We want to solve this for x, all right? So there's a theorem, okay? There's a theorem that explains to us how to solve, okay? That's this other box over here, all right? So what we need to do to solve exponential equations is we need to break both sides of the equation to the same base. Once you have both sides of the equation the same base, all right, then the theorem says we can move the base out of the way and set the exponents equal and solve, okay? So once again, you want to take both sides of the equation. You can see that the variable a is being used to represent the base, okay? So we want both sides of the equation, okay, to be the same number. Once both sides of the equation, same base, we can move the bases out of the way and set the exponents equal. So we come to this example right here. We want to break this example down. We want both of these bases to be the same number. So we can break 9 down to base 3. So we're going to keep the left side, 3 to the 2x minus 5. All right, and then what about the right side? 9, we can write 9 as 3 to the second power. Break both sides of the equation down to the same base. Once both sides of the equation are broken down to the same base, you can move the bases aside, set the exponents equal. Okay, so move the bases aside, set the exponents equal. We want to solve for x. Okay, so solve for x. Well, let's add 5 to both sides. Okay, so let's add 5 to both sides. All right, 5's cancel. Undo this, so you have 2 times x. Okay, equals 2 plus 5 is 7. All right, we don't want 2 times x, we're solving for x, so divide both sides by 2, and then so x equals 7/2. So here's your answer to the first equation, all right? So laws of exponents will come in a little bit handy with harder problems. We're getting there with the laws of exponents, but this is pretty much the strategy. You want to take both sides of the equation, break them down to the same base. Okay, so let's go ahead and take a look at example number 2. Okay, so example number 2, we're going to take the number 5, raise it to the x plus 3 power. Here's example number 2. We want to take 5, raise it to the x plus 3 power equals 1/5. Okay, so here's example number 2. 5 raised to the x plus 3 equals 1/5. All right, so how do we start? We want to take both sides of this equation, we want to break it down to the same base. Okay, so we want base, what do we want? Base 5? Base 5, let's break both sides down to base 5. The left side, we have base 5, 5 to the x plus 3, and we have base 5. How can I write 1/5 as base 5? Okay, I can write 1/5 as 5 to the negative 1. Okay, so negative exponent. Sometimes you have to go, the other way. So 1/5, 5 to the negative 1. 5 to the negative 1 powers 1/5 to the positive 1. Sorry. So solving exponential equations, first thing we want to do, break both sides down to the same base. Okay. Once the bases are the same, we can use our theorem. Once the bases are the same, move the bases out of the way, set the exponents equals. Take the bases, move them out of the way, we can set the exponents equal. So we can take x plus 3, all right, we can set it equal to negative 1, all right? And then solve for x. We don't want x plus 3, we want x by itself. So take 3 away from both sides, subtract 3 from both sides of the equation. 3's cancel, so x is negative 4. Here's your answer for example 2, x is negative 4. Okay, solve an exponential equation. You want to break both sides down to the same base, all right? Is it always possible to break both sides down to the same base? Not always possible, but that's the next video. Okay, so for this one right here, we're just going to do the introductory level of solving exponential equations. So we want to break both sides down to the same base. Keep in mind the laws of exponents and keep in mind the theorem. Example number 3. Okay, so I'm going to erase these. All right, so let me erase these. Let's put example number 3. Okay, example number 3, 9 raised to the negative x plus 15. So this is going to be 9 raised to the negative x plus 15 on the left side. This is example number 3. All right. On the right side is equal to 27 raised to the x power, so 27 to the x. All right, here's example number 3. 9 to the negative x plus 15 equals 27 to the x. All right, so we want to solve this exponential equation. We want to solve for x, okay? So what do we want to do? We want to look at the bases on both sides, 9 and 27. We want to break both sides of the equation down to the same prime base, okay? So the same base. What base can we use with 9 and with 27? Well, we can break those both down to base 3, okay? So we can take the left side, we can break it to base 3. We can take the right side, we have to break both sides down, break them down to base 3, okay? How can we write 9 is base 3? To write 9 is base 3, 9 is 3 squared, okay? So 3 squared is 3 times 3, 3 squared is 9, so to write 9 is base 3, 9 is 3 squared. How can we write 27 is base 3? So 27 is base 3. 27 would be 3 raised to the 3rd power. 3 cubed is 27. 3 times 3 times 3. Okay? So you want to break both sides to the same base. The same prime base that we can use here would be base 3. 9 is 3 squared. 27 is 3 cubed. Okay? Now we need to combine the exponents, all right? Now this is where you have a power raised to a power. Power raised to a power means we need to multiply the exponents, laws of exponents here. So we're going to need to multiply these exponents. All right, be careful when you multiply these exponents because you're going to have to distribute the 2 to each term. Okay, so make sure you take the 2 and it's going to be multiplied by the quantity of negative x plus 15, which means the 2 has to be distributed. So the left side you have 3 raised to the 2 times negative x, so negative 2x, and then 2 times 15, so plus 30. So on the left side, make sure that when you multiply the exponents, you're taking the 2 and you're distributing it to the binomial and the outside exponent. On the right side, again, keep the base, multiply the exponent. You have a power raised to a power, so keep the base, multiply the exponent. Okay, so we have that second law situation. So 3 raised to the 3 times x power. Keep the base, multiply the exponents, okay? So now take a look. Bases are the same. So when the bases are the same, you can move the bases out of the way, set the exponents equal. That's what our theorem says over here, okay? So once you get the bases, both sides of the equation the same, move the bases out of the way, set the exponents negative 2x plus 30, okay? Set it equal to 3x, set the exponents equal, okay? All right, and then we want to solve for x. Let's move the x's to one side. So maybe here add 2x to both sides of the equation. So add 2x, okay? So the x's on the left side would be gone. So we have 30. That's all that's left over here. 3x's add 2x's, so we have 5x, okay? We don't want 5x. We're just trying to solve for x. So we can divide both sides, divide by the coefficient 5 on that x, and so you end up with your final answer. 30 divided by 5 is 6, so x is 6. All right, so here's the answer to example 3, okay? So break both sides of the equation down to the same base, all right? And then finally, let's do one more example, okay? So here, this is example number 4, okay? So example number 4, we have 5 raised to the x squared plus 8. 5 is raised to the x squared plus 8 power, okay? We're going to set that equal to 125 raised to the 2x power, 125 raised to the 2x, okay? So this is what we have for this example. So, yep. All right, so again, we want to solve the exponential equation. We want to solve for x. Exponential equation is when the variables in the exponents, these are exponential equations. We want to solve for x, so the technique we're using, we want to break both sides down to the same base, okay? So you've got 5 for the base on the left, you have 125 for the base on the right. We can break both these bases down to base 5, okay? So the left side, we already have base 5, so bring it down to the x squared plus 8. On the right-hand side, okay? On the right-hand side, how can we write 125, okay? How can we write 125 as base 5? Okay, so 125 as base 5 is 5 cubed, 5 to the 3rd power, okay? 5 times 5 is 25, 25 times 5, 125, okay? So 5 times 5 times 5, all right? So break both sides down to the same base, all right? Left-hand side, so it's just gonna bring it down, it's all set, okay? All right, and the right-hand side, again, you have power raised to a power, okay? So when you have a power to a power law of exponents, we're gonna multiply the exponents, okay? So you're gonna keep the base and multiply the exponents, okay? So we have 5 to the 6x on the right-hand side, all right? So now, once both sides of the exponential equation, once both sides are broken to the same base, okay, what we do to solve this is we're going to take the base, move it out of the way, set the exponents equal. So take the base, move it out of the way, so you have x squared plus 8 on the left, and you have 6x on the right, okay? So x squared plus 8 equals 6x. And we have to solve this equation, all right? Unlike the other examples, this equation right here is a quadratic equation. Quadratic equation, so how do we solve a quadratic equation? We need to take all terms and move them to the left, okay? We need a 0 on one side and all terms on the other side. In this case, I'm going to move this to the left. I'm going to subtract 6x from both sides. I'm going to move this to the other side, subtract the 6x from both sides of this equation. So we have x squared minus 6x plus 8, okay, equals, and then on the right-hand side, the 6x's are gone, okay? All right, and then so there's a couple of different techniques to solving a quadratic equation. This one factors. This one, we can go ahead and factor this one, so sometimes solving by factoring might be a little bit easier. X squared is x times x, gives you the first term x squared, okay? Now we need to figure out what numbers give us a product of positive 8 and a sum of a negative 6, okay? So what's going to work there? Well, negative 2 times negative 4 will be our combination. Negative 2 times negative 4 is positive 8. The sum of negative 2 and negative 4 is negative 6, so this works out, okay? So what are your solutions to this? Well, your solutions to this quadratic, we could take either factor, okay? So this will give you, when each factor gives you a 0, okay? Set the left-hand factor here equal to 0, set the x minus 4 also equal to 0, solve for x. We don't want x minus 2, you want x by itself, so add 2 to both sides, okay? So x is 2, okay? Also, add 4 to both sides over here, so x, we don't want x minus 4, you just want to solve for x, so x equals 4. So you have 2 answers, 2 solutions for this equation, since it generated a quadratic. So x is 2, x is 4. All of the examples we've done, you could take your calculator if you wish, take the answers you get, plug them back in. Okay, plug them back in, just make sure the left and the right side work out the same if you wanted to check your answers over. All right, so there's a technique you want to use with solving exponential equations when both sides of the equation can be broken down to the same base, okay? So you want to just use the theorem over here in condensed form. So if once you get the bases on both sides of the equation to be the same, you can move the bases out of the way, you can set the exponents equal, solve that. So this concludes the video on solving exponential equations with the same base on both sides. So thank you for watching. I hope this helps. And again, stay safe out there. Thank you.